good morning, good afternoon, or good evening, depending on the time you are watching this. Today we're going to be practicing simplifying rational expressions. Just a quick definition. A rational expression is a ratio or fraction of two or more polynomials. Remember, polynomials are just different terms. So let's say we have 45 divided by 15. This is just another quick example of how to look at it as. If we divide this by 5 and we divide this by 5, what do we get? 45 divided by 5 gives me 9. And we have 15 divided by 5 gives me 3. What else do we know? We could divide 9 divided by 3 and 3 divided by 3, which is 3 over 1, which is also just 3. So we're going to be doing something similar to this. Another way you can look at it is, let's say we have x to the fourth divided by x squared. What does that mean? So if we have x, how many x's do we have? We have 4 x's, right? That means x times x times x times x divided by, how many x's do we have at the bottom? X times x. What would happen here? Two of my x's on top will cancel, two of my x's on the bottom will cancel. That gives me just x squared. So this is the same type of concept that we're going to be practicing. However, we're going to be doing polynomials. So the fundamental principle of rational expressions. If, remember, P is a polynomial, Q is a polynomial, and R are polynomials, then we can say P times R divided by Q times R equals 2 R times P or R times Q. And what's going to happen here? My Q's will cancel. This equals 2P divided by Q. However, this only works if Q and R are not equal to 0. Why is that? If this were to equal to 0, 0 times this would just give me 0, and it will be undefined. Another quick definition that you guys should write down is the fundamental principle allows you to reduce rational expressions to the lowest terms by dividing the numerator and denominator by the greatest common factor. So again, we could have divided this by something simplified a little bit more. However, look what we did here. We got x to the 4 over x squared. So when we simplified it, we got x squared. We're going to be doing the same thing, but however with polynomials. Okay, so I wrote down my examples already. So we're going to do practicing 2, 4, 6 problems today. So let's say we have x squared plus 2x plus 1. First thing we have to do is factor out the top term and the bottom term. So what can we say? We x squared plus 2x plus 1 over x squared minus 1. If we were to factor this out, if we were to factor the top part out, what would we have? Remember, parentheses x plus 1. This is going to be for the top part. Divided by, or times, plus 1 over. Now remember with this x squared minus 1, remember that was the difference of squares. That is the difference of squares. I'm going to draw a quick arrow. Difference of squares. The difference of squares. So the bottom part is going to look like x plus 1, close parentheses, open parentheses, close parentheses, times x minus 1. Now what do we do from here? All right, so this is what we're going to do. We're simplifying rational expressions. Now we have x plus 1 times x plus 1 divided by x plus 1 divided by, or times x minus 1. Now what do we see that we have in common? We have x plus 1 and x plus 1. So we can just go ahead and cancel that out. What would be my final solution? All this equals to is x plus 1 on top divided by x minus 1. And that is what we are doing. That is my solution. That is in the simplest form. Let's look at the next problem. We have 2x plus 6 times x squared plus 5x plus 6. Now, one thing I want to go back to, remember, if we wanted to check our answer, what can we do? X times x gives me x squared. x times 1 is 1x, plus 1 times x is 1x plus 1. So that would be 2x plus 1, and over here we have x times x gives me x squared. X times negative 1 will give me negative x plus 1 times x is positive x, and 1 times negative 1 gives me negative 1. So we're going to be, that's one way to check your answers. X plus 1 and x minus 1 is the simplest form. Looking at this, if we were to factor the top part, the numerator, if we were to factor the numerator out, what do we have in common? Well, from here we have 2x plus 6. We can factor out the 2 from each term, right? Divide this by 2, divide this by 2. So simplifying the top denominator, we have 2 times x plus, if we were to divide 6 divided by 2, that gives me 3. Again, how do we check it? 2 times x gives me 2x plus 2 times 3 gives me 6. Now this is going to be divisible by, what is my numerator? I'm going to factor out my numerator. Again, I'm going to use parentheses. And I'm going to have x and x over here. So it's x. Everything is positive. I'm just going to go ahead and put a plus sign there. And what are factors of 6 that when we add them up gives us 5? That's 2 times 3. 2 times 3 gives me 6. 2 plus 3 gives me that 5 that I need. So it doesn't matter where I put them. This becomes, and I already factored out x squared plus 5x plus 6 gives me, factored out, x plus 2 in parentheses times x plus 3 and the second set of parentheses. Now what do we see that we have in common? Well, on the top part, we can cancel out what? X plus 3 and x plus 3 at the bottom, right? X plus 3 and x plus 3, that just gives me 1. What do I have left? I have 2 divided by x plus 2. This is in the simplest form, and that is my final solution. So hopefully you're understanding what's going on here. I'm factoring out the top term, and I'm just rewriting it in the simplest form, simplifying rational expressions. From here, this will allow me to find my zeros a little bit easier. Just keep that in mind. Now we have x times a minus b plus 2 times a minus b divided by a minus b. Now what do we have in common? Obviously we have a minus b, a minus b, a minus b. Now we're gonna put x plus 2 in its own parentheses, because when we distribute this, we will end up in the same form. However, I'm gonna keep my a minus b for my numerator, a minus b. All right, what am I multiplying this by? I'm multiplying them by x times 2, right? Or plus 2, right? So I could write another set of parentheses, and then I have x plus 2 and what do I have in the bottom? I just have a minus b, correct? A minus b. Now, what's our last step? No, it seemed a little bit confusing. A minus b and a minus b divided by that, we just cancel out, or equals to 1. What is my final solution? Excuse me. I have x plus 2. That's it. Next problem. We have 3t plus 15. And we have t squared minus 25. Remember, t squared minus 25, it is the same as x squared minus 1, which is called what? Our difference of squares. So we have our formula, x plus a minus x minus b. We're going to do the same thing with this. Now we have 3t plus 15. What can we factor out from my top denominator, my 2 terms on top? I'm going to factor out my 3 from both terms, right? These are common. This is my greatest common factor from my top term, 3. If I divide this by 3, what do I have left? I have t by itself. If I divide 15 divided by 3, what do I have? 5. All right, so on my numerator, I think think I might have said denominator earlier. I'm going to factor out my 3. All right, what do I have left? T plus, and 15 divided by 3 gives me 5. All right, remember we were talking about our difference of squares. So that is parentheses, 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 parentheses. And t squared minus 25. What is 25 squared? Or the square root of 25? I have t plus 5 and t minus 5. All right, so what do I have left? T plus 5 and t plus 5. What can I do there? As usual, I can cancel that term and that term. That gives me 1, right? What do I have left? For my numerator, I just have t by, or 3 by itself, excuse me, divided by, and what do I have left? T minus 5. Pretty simple so far. All right. Now these last two problems are a little bit trickier, or especially this one, but it's not as tricky as it seems. Now I have a squared minus 12a plus 36 on my numerator, and my denominator I have a squared minus 3a minus 18. So right here we have two negatives. Up here we have a negative and a positive. So I have two negatives right here. One of these is going to be positive, and one of them is going to be a negative when I factor it out. And what's going to happen? I'm going to have a bigger negative sign, right? Because of my negative 3a here. So over here, if I add up two negatives, or negative times negative will give me positive, right? And if I add up those negatives, then I get positive or negative 12a. So just keep that in mind. Look for little signs like that. So again, I'm gonna start off with my parentheses. And if you want, just go ahead and put your fraction in the bottom. I know it's a big fraction, try to keep a straight line. Parentheses, 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 parentheses. So let's just fill in the blanks. What do we have? Well, what are my factors of 36? Well, we'll start off with 6 times 6, right? 6 times 6 gives me 36. However, the 6 times 6, if I add them up, does that give me negative 12? Not that. However, negative and negative, right? Negative 6 times negative 6 gives me positive 36. If I have negative 6 plus negative 6, what does that give me? Negative 12. So up on top, I have a minus 6 and a minus 6. What else can I do? Anything that is in simplest form. On the bottom, what do I have? I have 18 and 3. So I kind of can see what's going on here. This has to be multiplied by negative 6 times positive 3. What else could we use? 9 times 1, we could try that out. Or 9 times 2, excuse me, 18 times 1. However, if I multiply positive 3 times negative 6, what does that equal? Negative 18. Now, if I add up negative 6 plus 3, negative 6 plus positive 3, what does that give me? That gives me that negative 3a that I want, or negative 3 that I want. So I have a, and then one of them has to be negative 6, so I'm gonna put minus 6 on this side and plus 3 on my other side. What's gonna happen now? All right, so which ones can I cancel? A minus 6 and a minus 6, what does that equal? That is just 1, so that cancels and that cancels. So my final solution will be a minus 6, a minus 6, again, I like to put them in parentheses, and a plus 3, close parentheses. All right, again, final solution. A minus 6 and a plus 3. What do we have over here? We have 4x times y minus 2z and 2x to the power of 4 times y minus 2z. Now, what do you see right away? Instantly, what do you see? In the parentheses, we have y minus 2z and y minus 2z. So if we divide that, what do we get? 1, right? not 0. Not a 0. What's next? We have 4x divided by 2x to the 4th, right? So I'm just going to rewrite it for you guys. I have 4x divided by 2x to the 4. Now, we know 4 divided by 2 gives me 2. Now, let's look at my x's. I have one x on top and x to the 4th on the bottom. So remember I did it earlier on the quick example. So let's just show you how this works. Again, I have x times x times x times x. X times x times x times x. Why is it 4 x's? Well, I got a power of 4 and 1 x on top. Now, how many x's can I cancel out from the top and the bottom? Well, I can cancel 1 and 1. What do I have? X to the power of 3. In other words, x cubed, right? So my final answer will be 2 times x cubed, or 2x cubed. That is my final solution for this last problem. Those are all the problems that we worked on today. I know it's a little fast, but I mean, it's not a lot of work. Just take it step by step. Make sure you understand how to factoring. If you do not understand how to factoring, I posted up some YouTube or on my Instagram on how to factor. Now, for today's problems on simplifying the rational expressions, we're gonna practice. I put 8 problems for you guys to try to work out. Ask questions if you need any help or assistance. So let's start off. I have 8a minus 48 and a minus 6. Now I have a minus 6, so that means I'm gonna have to cancel this out somehow, right? So one of these top terms, when I factored it out, I'm gonna have a minus 6. So somewhere up here, you're gonna have a minus 6 as well, and that should be able to cancel that out. On this side, we have x squared minus 11x plus 30. Now look at this, negative 11, right? And this positive 30. What two numbers? They're gonna have to be negative. Negative times a negative number, that will give me 30. And when I add up those negative numbers, will give me 11x, or 11. And then on the bottom, I have x squared plus 2x minus 35. Again, I have a negative 35 and a positive. So make sure you have a negative number times a positive number, that when we add those two numbers up, will give us positive 2. All right, so I have a minus 2, right? So down here, I must have somewhere a minus 2 times something. So just be careful. We have a negative and a positive 18. I can already see what's going on here. All right, let's look at this one. We have 28x squared plus 42x plus 14 divided by 20x, that is a square, minus 22x minus 16. What do they have in common on top? What do they have? Let's factor this out. As with a big positive number, we're gonna have, I don't want to give you any hints, but yeah, so we can just factor this out by what number? Think about 14, 42, and 28. What is a common factor between all three of those? Then we have 20x squared minus 22x minus 16. Again, what is a common factor between all three of these? Over here, I have x minus 7. So I have divided by x squared plus x minus 56. So what two numbers, when we multiply them, will give me 56 and give me that positive 1 that I need. Next problem, we have x squared plus 4z minus 5 times, or divided by x squared plus 8z plus 15. My last problem, I have x squared plus x minus 2, not my last problem, problem number 7, and x minus 1. Again, you're gonna have to have x minus 1 somewhere up here so they can cancel each other out. Last problem, I have 2x minus 10 divided by x squared minus 10x plus 25. What is a common factor between 2x and minus 10 on top? And all right, so now let me show you the solutions. These are the problems and solutions. Remember, we are talking about simplifying rational expressions. So I'm gonna leave this up here for a few minutes so you can take a screenshot of it. And that is it for today. Good luck. Next topic, we're going to be talking about the quadratic formula. It is a formula that you will be using throughout high school, pre-calculus, calculus, and so on. That's going to help you finding the zeros. All right, until next time, have a good day, have a good evening, and I'll see you soon. Thank you for watching.